Hi, this is Mr. West, and today we're doing a Khan Academy tutorial on solve exponential equations using exponent properties. Before you start, if you do not know exponent properties, particularly what happens when you multiply bases, when you have power raised to a power, and also negative exponents, I'm going to be referencing those things. So I have those videos available if you want to check them out. That's negative exponents, and then power rules, exponent rules. Those would be important to see before I start this video. Now, diving into this problem, these look extremely complex and complicated, and they're really not that bad once we break it down. One of the main things that we're going to utilize here is we're going to utilize trying to get these bases the same. For example, if we know that 2 to the, let's say, third power equals 2 to the x power, we can clearly see that x is going to be equal to 3 because the bases are the same on both sides. We have a 2 there, a 2 there. So obviously, the exponents need to match. X needs to be equal to 3. We're going to try to do that here. We are going to try to get 1 over 27 to match 3. But how do we do that? So the way we're going to do that is we are going to see if we can use 3 as a base with a certain power to get those to match. You should recognize that if we have 3 to the second power, that's 9. 3 to the third power, that is 27. So we're close there with 3 to the third power. However, you'll notice that 1 over 27 is not just 27. So we need to change this to a negative exponent. 3 to the negative 1 power is 1 over 3 to the first power. 3 to the negative 2 is 1 over 3 squared. And 3 to the negative 3 is 1 over 3 to the third power, or 1 over 27. So that's like a cheating way, I don't want to say cheating way, but it kind of is, of how we can get this base to match. Instead of writing 1 over 27, we are going to instead write, whoops, I wanted the highlighter instead. We are going to instead write 3 to the negative 3. So we're going to replace this, okay? And I kind of covered it up, but that's okay. We're going to replace it with, I'm going to write it in green, 3 to the negative 3 instead of 1 over 27. The left side is going to be the same. So we have 3 to the 7 minus 2x, and then we replace that, and that's still to the negative 8 power. Okay, I think we're ready to move on from here. And the reason why is we're going to apply one of the power rules, which is a power raised to a power. We're going to multiply those two exponents. When we multiply negative 3 times negative 8, we're going to get positive 24. We still have that base of 3. And then on the left side, we still have it equal to 3 to the 7 minus 2x. See how we were able to change these two unlike bases to match now? And from there, we can say, hey, 7 minus 2x and 24 both need to be the same. Let's solve for them just like a two-step equation. So I set it up. 7 minus 2x equals 24. I'm going to first, let's say, subtract 7 from both sides. I have negative 2x equals, I think that's 14, isn't it? 17. And then I'm going to divide by negative 2 when I'm done. And so my answer is going to be x equals 17 over negative 2. And that's what value of x will make that true for this exponential equation. So I need to type in 17 over negative 2 or just negative 17 over 2. Which I prefer to do. Negative 17 over 2. I like to put the negative in the top. And there we go. Done with the first one. Okay, now that you got the hang of it, hopefully you recognize that, again, our first objective is to get these bases to match. We have 3 and 81. I hope you guys see that we have 27, 81 as a power of 3. So if you do 27 times 3, you're going to get 81. So that's 3 to the fourth power. What does that mean for us? Well, that means we are going to rewrite 81 as 3 to the fourth power. On the left side, it's going to stay the same. On the right side, like I just said, we're going to write 3 to the fourth power instead of 81. But we still have that 5x plus 1 exponent there. How do we handle this situation? Still the same thing. We're going to multiply those exponents. Okay, so once we do that, we got to treat it like this, where we have the distributive property. So we're going to do 4 times the 5x, that's 20x, and then 4 times the 1, That's 4. So this becomes 20x plus 4, still of a base 3, and on the left side we have 3 to the x minus 9 power. Now these two bases match. Guess what that means? We can set those two exponents equal to each other. I'm going over here now, looking for extra space. 20x plus 4 is equal to x minus 9. I like getting the x's together first, so I'm going to subtract x from both sides, and that gives me 19x plus 4 is equal to negative 9. I'm going to subtract 4, and that gives me negative 13 equals 19x. And now I finish it off by dividing by 19. It's okay, just leave the fractions. You can type in the fractions as answers, and it doesn't make a really big difference. Okay, so I get negative 13 over 9. It's kind of not reassuring when you get answers like that, but you know, sometimes that's what you get. So negative 13 over 9. Let's test it out. Is that what I said? Ah, good thing I double checked. Negative 13 over 19. I like to double check my work. Occasionally I write down the problem wrong in these videos, and then I check my answer and it says I messed up. I know that happens to you too. All right, this one's a little bit easier because we recognize that we have 5 and 25. Those are clear powers of each other, so 5, 2x plus 7. And then we could rewrite this. I hope you guys don't mind me kind of speeding this process up. We could rewrite that as 5 squared. So this is 5 squared raised to the 1/3 power. Okay, I think you guys are getting the hang of this. We're going to multiply these powers now. That's supposed to be an m. And we get to the 2/3. 2 times 1/3 is just 2/3. Everything else is going to stay the same. Lo and behold, these two exponents are the same now, so we can set those two equal to each other. 2x plus 7 equals 2/3. I don't like it when there's fractions. I like getting rid of the fractions. So what that means for me is I'm going to multiply everything by 3. It cancels out the fraction on the right. I need to distribute, so I get 6x plus 21 equals 2. See how I know I don't have fractions anymore? I think that's awesome, personally. Minus 21, minus 21. I'm going to get negative 19 and then 6x on the left. And then I divide by 6. And I get negative 19 over 6 as my value for x. Let's type that in. Negative 19 over, I said it immediately and forgot. All right, we have one more to go. Okay, this one looks a little bit difficult, but again, this is going to be a negative exponent reference. 7 to the negative 1 equals 1 over 7. 7 to the negative 2 equals 1 over 49. This is what we're going to use right here. Okay, so instead of writing 1 over 49, we're going to write 7 to the negative 2nd power. 7 to the 3 over 5 minus, or sorry, 3 minus 5x. 7 to the negative 2 to the power of 2x plus 9. Okay, again, we're going to multiply these two. We're going to have to distribute. So that looks like this. Negative 2, 2x plus 9. Get negative 4x minus 18. So negative 4x minus 18. That's of a base of 7. Over here's a base of 7. And you guys know what to do from here. These match up. Okay, so we're going to set these equal to each other. 3 minus 5x. Negative 4x minus 18. I like to get the x's together first by moving the smaller of the two. So the smaller of the two is actually that minus 5x. I'm going to add 5x to both sides. Once I do that, I need to slide it over here. X minus 18, and that's equal to 3. I'm going to add 18 over here, add 18 over here. Wow, I'm almost afraid that this is a good answer, like a nice simple answer. X equals 21. Just going to double check my work here real fast. I added 5x. I got x as my answer. I added 18 to move over. Want to see if I copied it down correctly. It looks like everything's good, so I'm just going to go ahead and try it. Hopefully it works out. We're going to type in 21. Check it. Hold your breath. There we go. We got it. So I hope you enjoyed this video. Make sure to leave a comment if you need anything specific covered again on this topic or a different topic. And I look forward to seeing you next time right here on Wes Explains Best.